when air is flowing up the slope and it's moist, you have what we in meteorology, what you're looking at is say like a stalled upper level low pressure system just down in Washington State, Northwest US, and it kind of redirects this easterly flow, this moist easterly flow into the terrain, and it forces it up. And if it's sitting there for a day or two, you can get some significant precipitation. A very similar setup to the Calgary floods in 2013, actually, just a different season. So, I mean, you can get a sense for just how much snow comes with these events. So what does a weatherman do? He takes a walk through the snow. You got to wade through that waist deep snow, right? Okay, how about strong winds associated with these winter storms? Of course, blizzard conditions can be incredibly intense. There's also some occupational hazards that come along with that, as it turns out. Yeah, so high winds, not so good when you try to set up a tripod on, out in the middle of the wind. That occurred in Manitoba, Thanksgiving weekend 2019. And that snow, if you look carefully, I have a laser pointer here. Look at the pole and you can see how the snow is kind of stuck to one side, the north side of these poles. It's like snowcrete. Oh, sorry, that was loud. Snowcrete, like concrete, but it's snow because it's so wet. And it was stuck to these lines, and the added tension from the 90-kilometer-an-hour wind gusts caused some of these gigantic steel transmission towers to buckle. And I've never seen that with snow. Freezing rain, perhaps, but not snow. Okay, so like I was saying about the wind, the air flowing up the slope of the terrain, if it's flowing down slope, we're all familiar. Some of us like Chinooks, especially in the winter time. It brings a break from the cold. Maybe you get headaches from it, though. That's not always great. I'm going to start playing the video here. Of course, they're more common in the winter. You need that stable flow going over top of the Rocky Mountains. So what's happening there is, of course, it's a stable air mass. It goes over the mountains. So if it's stable, it's kind of resistant to vertical motion. So if it's flowing over the mountains, it gets forced up and then it wants to go back to equilibrium, and it actually overshoots and goes down. It has momentum because it's flowing. And then it shoots back up. And of course, in the blue sky there, that's where the air is sinking. And then where it comes up in that first primary lee wave east of the Rockies. So it goes over the mountains, down, which is where it's clear. And then it shoots back up. And that first primary lee wave is where you get that Chinook arch that forms. So really cool. And when you saw that time lapse there, basically these clouds, you can see how the cloud itself is stationary, but the air is flowing through it. So very interesting. Other very interesting cloud systems with these mountain waves is look at this plate stack, this lenticular stack. You can just see all the different layers in here, and that's because the atmosphere is stratified with different layers of relative humidity. And when you force it up over a mountain barrier, it condenses at different heights, and you get these plate stack appearance. Just fantastic lenticular stack there. It was also very incredible. That's from my balcony in Calgary, but it was also seen from Pincher Creek. How about that? That's a rotor cloud. So that's a violently rotating horizontal column of air underneath that mountain wave I was talking about. And there's obviously some extreme air turbulence associated with that. And then you can see here in the foreground, 160-kilometer-an-hour wind gusts. This is time lapse, obviously, but yeah, just look at that snow blowing off those peaks. So yeah, I mean, that's obviously aircraft are going to be staying away from that. That's going to be some extreme air turbulence in there. So what's a weatherman do? Well, he's going to go stand on the top of a mountain to kind of see what that wind feels like as it's blowing, right? Okay, so you can see this. This is a weather station up there. This is an Environment Canada weather station. That is probably the windiest station in the country. It sits in the lee of the Kananaskis Range, so the downslope flow goes over the top and collides with the top of the mountain. Unfortunately, in this wind event, I only documented 124-kilometer-an-hour wind gust. So what's a weatherman do? Well, he's got to go back up there and see if you can get a higher gust, right? This is the next year. Kids really like that. When I do schools, they love just watching me get my butt kicked up there. There's the station again, just steady. You know, sometimes it actually gets knocked offline. It's registered gusts over 200 kilometers an hour on occasion. So when I was up there, 193 kilometers an hour that time. So I about 170, 180 is where I started to have trouble standing up. If I go do that again, I'll definitely be wearing knee and elbow pads because it is no fun rolling around on the rocks up there. It's not like I'm going to get blown off the top of the mountain per se, but yeah, it's kind of rough as you can see. So yeah, I mean, we have other hazards associated with those winds. If you're a big rig driver and you've got little or no load that you're towing down the road, especially highways 2 and 22 in the southwest corner of the province, they run pretty much perpendicular to the parallel to the terrain. So the wind is like a pure crosswind, right? You are in the southbound lanes, especially banking hard to the left, that wind can get up underneath the truck and bad things can happen. So unfortunately, yeah, this guy tipped over right in front of me. But fortunately, he had very minor injuries. He had a scratch over his eye. He was really shaken up. He didn't have a good time. But we made sure he got out of there okay. Yeah, that typically happens every significant wind event, Chinook. You know, once the winds get above 100 kilometers an hour, you start to see trucks tipping over on Highway 22, Highway 2, south of like Claire's home, Nanton, Granham area. That's where that happens. Shifting gears a little bit here. Simon mentioned earlier that I used to be a wildland firefighter. That's the case. I was a member on a rappel crew, the now defunct rappel program here in Alberta. So I'll just show a quick clip from what that's like before we dive into a little bit of wildfire stuff. Whee! So much fun, right? Okay, so wildfire season in Alberta, typically May, June. Also the boreal forest, northern BC, Alberta, Saskatchewan, Manitoba. It's what we call the spring dip. The snow has melted, but the sap hasn't gotten up into the trees. So the trees are really dry, have low, really low foliar moisture content. So we call that the spring dip. Fort McMurray fire, early May 2016. It's typical wildfire season. British Columbia, on the other hand, tends to be later in the season. Once that fuel has been baking in the boiling hot temperatures. So here, as you can see, Lytton, BC, Canada's hotspot. Yeah, 2021, it was very, very hot that year. I was documenting the heat, hit 49.6 degrees Celsius on June 29th. So, of course, what's a weatherman do? Initially, some hot weather experiments. Try to boil an egg in a pan. How do you think that went? Any guesses? Spoiler alert. It was really disappointing. Basically just slowly evaporated. I had it sitting in the sun for a long time. I was like, what? It's not boiling at all. So, okay. So really bad things happened later on though. As I drove home after that, it was this absolutely massive pyrocumulonimbus cloud took off. Fire generated thunderstorm. And I shot some footage of it. And I'll let you watch this for a second. I'm just going to grab a drink of water. So as you can see, it was very intense there. On the June 30th, we had 40 degrees, like 60-kilometer-an-hour winds just rushing up the Fraser Canyon. And unfortunately, a fire burnt over the village of Lytton in a matter of like 15 or 20 minutes. I was documenting that fire at the time. These fire-generated thunderstorms, these pyrocumulonimbus clouds, can grow like 15 kilometers high and inject that incinerated biomass, that smoke, way up into the stratosphere, where it can kind of drift around for days and weeks even. But later in the summer, it continued. It was a bad summer. This is Vernon on mid-August, and really strange things happened. The sky just suddenly turned orange one evening while I was there in mid-August. The city was under an evacuation alert, and so that's a city of 40,000 people. It was pretty nerve-wracking. But here's what the sky looked like there. Orange cast. Even pavement, you might be able to see sidewalks are starting to turn orange. Just all around it, like street lights are starting to turn on. You can see down this street here. Okay, so yeah, really scary stuff, right? Even the next day, okay, it gets even worse. Yeah, I'll just let you watch this. Basically, it turns pitch black in the middle of the afternoon. Listen to the crickets. Smoke is getting thicker. Yeah, I'm good. Thank you, sir. Go inside here. 4:41 in the afternoon, 33 degrees. Unbelievable. This is just absolutely incredible. I have never seen anything like this in my life. Spooky stuff. So that was mid-August, British Columbia. And basically what happened there was the White Rock Lake wildfire just west of Vernon. There was another one near Kamloops called the Tremont Creek fire. And I think basically what happened was both plumes were kind of stacked on top of each other and just blocked all the daylight out of the sky. It was very terrifying to see. So yeah, I mean, that week was very intense in British Columbia. Basically what had happened was you had like an unprecedented heat wave. Maybe some of you heard of it. It was called a heat dome. That's just an anomalously strong upper level ridge of high pressure that's just causing sinking air. And we had, it was near summer solstice, so the sun is very high in the atmosphere, or sun is high in the sky. The ground was dry. So it's just like everything coming together. And Lytton is the hot spot in Canada, quite often in the lee of the coast mountains in BC. So yeah, it was just a very intense event with heat. And like I say, those cumulonimbus clouds that you saw earlier, they were generating lightning strikes that were causing new fires. And it was just an incredible week, and not in a good way. Okay, switching gears once again, severe weather in the summer. This is my personal favorite. Actually shot this picture from our balcony downtown, May 31st, 2020, 3:30 in the morning. And actually, I thought that it had hit, we were sitting in the living room. I thought it hit Brookfield here. And lo and behold, I was scrolling through the camera and I was like, oh my goodness, it hit the Calgary Tower. So I was pretty excited about that. That's the first time I've ever seen that. And I've been looking for it since and before that, and I haven't seen it again. Like they say the CN Tower in Toronto gets hit like 40 or 50 times a year. But yeah, it doesn't happen that often on the Calgary Tower. This 12 hours later, there was a tornado just outside of Irricana. Now, as storm chasers, we typically we don't want to see damage, right? All of us would be happy seeing these tornadoes just out over open fields, not impacting any homes. I took this picture and sent it to the guy whose house that is, and I said, "Look what went through your field. It didn't touch his house, thank goodness." But that's a good scenario for what happens. But storm chasers can offer a lot to the community as well through their reports. They can contribute to science. They can also contribute to weather warning process. Meteorologists are looking for that ground truth that storm chasers can provide in the field. Now, many people think that the most hazardous part of storm chasing is the hazards of the thunderstorm itself, the tornado, the hail, the lightning. They are hazardous, but actually it's driving. That's the worst thing, right? I mean, people are not thinking straight near big, scary storms. You've got, inclement road conditions. You just have to keep your head on a swivel when you're near these big storms. So that comes as a surprise to some folks, but yeah, it's the roads that are the worst part of being near these storms. That being said, sometimes you get stuck in hail. So here's what it looks like to get hit by tennis balls. Yeah, I'm wincing there. I actually jumped outside of the car a moment earlier to collect some hail because I was doing live hits from inside the vehicle. There's no way I'm jumping outside the vehicle in that kind of weather, right? They were like, Kyle, do a hit in the hail. I guess you're stuck in there now, right? So my earpiece kept popping out of my ear, and that's why I was struggling. And I actually missed that hit. They probably threw to me and then saw me freaking out trying to get my earpiece in because it was really slippery from being out in the rain. And anyway, yeah, so TV doesn't always go according to plan. Sometimes you have some issues, and sometimes you get hit by big ice when you're out storm chasing. It's pretty much inevitable. I mean, in Calgary, you don't necessarily even have to be storm chasing to have damaging hail, right? Like June 13th, 2020 was Canada's costliest ever hailstorm. Northeast Calgary in particular was impacted, and there was $1.2 billion of insurable losses with that storm. Fourth costliest disaster in Canadian history and the costliest hailstorm in Canadian history. And this is a trend through the last decade or so. Alberta is a hotbed for severe weather, and that's pretty much due to our unique geography here. We've got moist croplands next to mountains, and we've got the mean jet stream position in the summer across the province. And so you've got moisture as fuel for storms, you've got lift along the mountains, and you've got that wind to organize these storms. Interestingly here, what you're seeing there is a tornado had actually drilled a path through this nice, lush, mature barley crop north of Calgary in July 2019. And these crops, when they are maturing like this, you will see a corresponding increase in severe weather. So there's about a 3 or 4 week period where canola, wheat, barley, they're all maturing. They're giving off root zone moisture through the stomata and the leaves and the plants. And there's me down there on the bottom flying my drone. But yeah, you will see these plants giving off a ton of moisture, and that feeds as fuel for these storms. So you will see the largest hail, the most significant thunderstorms, tornadoes, well timed to when these plants are actually transpiring all this moisture, assuming there is good ground root moisture. So interesting fact. This is a supercell thunderstorm. Now, a supercell thunderstorm is a rotating thunderstorm. So it has a deep, persistent, rotating updraft. It just goes up like this. I'll hit the time lapse in a moment here. Basically, what you need for that is wind shear in the atmosphere. That's basically you've got a change in wind and direction, wind speed and direction with height. So say it's, in this case, probably a southeasterly wind at the surface. Down here, it's streaming in from this direction, and then aloft, it's coming in from the southwest and imparts this rolling motion in the atmosphere, and that gets sucked up by a thunderstorm updraft, and you start to get this deep, persistent, rotating updraft. These are fairly common in Alberta summers. They are the least common type of thunderstorm in the world, but they are disproportionately associated with the worst thunderstorm hazards, so the large hail, the damaging winds, and the tornadoes. Speaking of tornadoes, this is July 7th of this last year near Bergen, Alberta. There was an EF2 tornado that touched down there, did some damage. And this is the moment when it initially spun up. Look at that weird little vortex just spinning up. So that was when, like, actually, if you, actually, you can kind of see, I don't know if you can see from back there, but these two little things, there's like chunks of someone's roof flying around up there. So we didn't actually even know that the tornado was ongoing yet. This little spin up that you just saw was the first evidence that we saw of a tornado. Okay, so before I start this one, take a look at the picture there. You can see this cut, this kind of clear cut coming here into the base. This is the base of the thunderstorm. That's the updraft base. And then this cut here, I'll talk about what that is. So tornado genesis, that's the term for the formation of tornadoes, is still fairly poorly understood. But basically, you need two main ingredients for any kind of tornado. That's a source of spin near the ground and something to stretch that spin in the vertical. And so that's typically an updraft. We already talked about the mesocyclone, which is the rotating updraft. So that's typically what's going to stretch it. But if you picture like a figure skater pulling their arms in, decreasing that axis of rotation, they spin faster. And that's the same thing. An updraft will basically kind of stretch it and it'll spin up a lot quicker. So what's happening here is we've got what's called a rear flank downdraft wrapping into the base of the storm, and it kind of occludes this updraft base, and it causes it to spin faster through convergence. And at the surface, it causes those little vertical swirlies we were talking about. And as you can see here in this time lapse, This thing went for 30 minutes or so. Just incredible rotation. That whole storm is strongly rotating. So here it is. Here, the tornado touched down back here somewhere, kind of did a little loop and then came back across the road. EF2 damage, so winds estimated between 180 and 220 kilometers an hour. You can see it's pretty big back in there. And then another strange thing that can happen, look at these individual suction vortices that happen. So the actual tornado cyclone is a lot wider, but you get these smaller, more violent tornadoes inside the larger circulation. And so if you've ever heard of, like, you know, one home getting destroyed and another next to it being untouched with the tornado, this is often the case. Is you'll have these multiple suction vortices going around the larger tornado, causing localized damage. Friends, here, it's hard to see through the rain, but I was, the latter half of the tornado, I was streaming live on the Weather Network. That was the first for the Weather Network to do it live on TV. And you can see this big cone back in here. So here's just a clip of it. Big tornado. It's stovepipe tornado ongoing. It's hard to see with the rain wrapping back there, but we currently have a large tornado ongoing here in south central Alberta. This tornado has been ongoing for the last 20 minutes or so, and it's kind of just sitting in one spot. It looks like it's fully wrapped around there in rain. There you go. There's a clip of that tornado. Okay, check this out here. This is a 2x6 impaling this home. So obviously one of the greatest hazards associated with severe thunderstorms, tornadoes, is the wind, right? You can get missiles flying around, literally. This actually wasn't even a tornado. This is in Eston, Saskatchewan in 2019. And 2 doors down, 150 kilometer an hour straight line wind gusts. So the thunderstorm's got a big downburst wind, right? Like a downdraft hits the ground, spreads out in all directions. You get straight line winds on the ground. Saskatchewan folks call them plow winds. It hit a house about 2 doors down, obliterated the house, and there you go. A 2x6 went right into that guy's living room. Other tornado damages, we were talking about missiles or these projectiles. This is a tree branch here stuck in the corner of a house in Carmangay, Alberta, when a tornado struck in also the summer of 2019. And guess what happened? It came right into his living room, right above the fireplace. So yeah, I mean, and that, again, that was EF2, so between 180 to 220. That last photo, sorry, this one was 150 kilometer an hour winds. So you don't even need it to be that strong. That's always a good idea to get indoors, stay away from windows, make sure you close your garage door, your front door. Like, a lot of people don't think about that, but if you're going to have like sudden positive pressure, hitting the front of your house, that's how doors and windows and even roofs will fly off. So that's why we always say to get indoors, get to the lowest level possible. If there's a tornado watch or a severe thunderstorm watch in advance, you're taking those preparations. You're moving your lawn furniture, you're securing loose items around the yard. So what happens here? This is in Carmangay as well. Back to this image. So these folks are taking shelter. They're doing what they're supposed to, going down to the basement, and they look out the window of the basement, and there's the family dog out in the yard trying to stay on the ground, and the tornado's approaching the yard, and she was kind of clawing at the ground, and she got carried away by the tornado, and they thought she was gone. She just like got sucked right out of the yard, and then there she was 2 hours later, came back into the yard. Like, she just walked. She was a little muddy and shaken up, but she was okay. So it was pretty miraculous. That's not the first time I've seen that happen. In Manitoba, there was another tornado where there was a family of 14 in the basement. The whole house got ripped off the foundation, and the family dog went with the house, and like 2-3 hours later came back into the yard. So, like they say, cats have 9 lives, man. These dogs, they just, yeah. So something else happened here. You can see there's a lot of damage. This is actually the shed on the property, so not the house, the actual shed itself. We were doing damage survey around the property, and we started hearing like a crying sound, like a little cat crying or something like that under the rubble. And the homeowner asked, they approached and said, like, what are you doing? What do you hear? Can you hear something? And I'm like, yeah, I think I can hear like a cat or something underneath there. And she's like, oh yeah, we're missing a kitten. So now we're in a rescue mission here. And I actually, if you listen carefully, there's a video clip here. You can see what that was like trying to find this kitten. With my old little sign off there. Yeah, so that was, I guess, the one happy ending for when we arrived back on scene after the tornado there. I don't normally dress like that when I'm doing news reports. You could see I was in like sweat shorts and like a t-shirt, but that was actually kind of like a last minute trip because the tornado came kind of unexpectedly. So there's the kitty. And yeah, little calico kitten, and obviously it was happy to be reunited with the little sibling, and then of course the little boy who's holding it was super happy to be reunited with this kitty. Okay, to round out the presentation, I wanted to show you some of the incredible damage shots that I got. Documenting, it was like my first major assignment with the Weather Network. It was documenting the tornado damage of the Alonza, Manitoba, August 3rd, 2018. It was an EF4 tornado. That's winds in excess. It's 270 to 310 kilometers an hour. It was the most violent tornado in North America and possibly the world that year. And you can just see there was a property nearby with like 280 hay bales, and like 200 of them went flying into Lake Manitoba. This is a mangled flat deck. This is, if any of you have ever heard of the Pine Lake tornado in Alberta, July 14th, 2000 rather. Tornado impacted the campground on a Friday night, and it was the August long weekend, so there was a lot of people there. There was actually a cell tower in the area, but it wasn't working because they were doing some construction nearby, and they had to turn it off. And so nobody got a tornado warning on their phone, and there's a big wall of trees beside the campground. So there was like this last minute effort to try to flee the campground. For obvious reasons here, you can see you do not want to ride out a tornado in a trailer. They're just really flimsy. You always want to get to lower ground, away from windows, or at least a sturdy building. And thanks to the quick thinking of many of the residents near the beach there, like here's a house completely slabbed clean. The house is gone, and all that's left there is the foundation. And actually the rating came, the EF4 rating came when the surveyors saw this damage here. But basically some nearby residents hid the campers. There was probably 50 or 60 of them in their basements, and they survived as a result of that. There was one fatality, but it could have been a very tragic night. On the night of a long weekend, tornado goes right through a campground. Incredible damage around the yard here. These big mature trees over here, that's where they were. Like they ripped the trees and the roots out of the ground. Like incredible. We call this when the trees are denuded or they're debarked. Like the wind, imagine a wind strong enough to rip bark off a tree. Like that's the type of wind we're dealing with here, and it just totally mangles and twists all the tree limbs off. Also incredible here, this is a potato garden. So keep in mind, there's typically about 18 inches of topsoil on top of this garden, and it just scoured it all off and exposed all the potatoes underneath. So just, yeah, violent winds. You do not want to be above ground when that's happening. Campground restroom, there you go. 3 of the 4 toilets still intact. This one we will rebuild. You can see even, hey, there's the toilet brush. I looked in the toilets, there's still water in them. But the building that was around it, it's gone. It's somewhere over by the lake. So yeah, that was one of the more strange things that we saw at that campground. But for the most part, storm chasing on the Canadian prairies, most chasers, photographers are happy with just these beautiful scenes. These are severe storms with no tornadoes, but there's just incredible structure. This is the supercell that we're talking about here. So this storm's rotating up here, just broad, slow rotation. This is what we call a shelf cloud. This is what we call a beaver tail right here, just smooth and laminar. And, some nice foreground here with the train tracks. Of course, I took these shots. This is in South Central Saskatchewan, July 17th this last year. Likewise, Southern Saskatchewan is a photographer's dream for many reasons, but when you get severe storms, it's doubly so because you get this beautiful storm structure. This is a shelf cloud, multi-layered, multi-tiered shelf cloud just barreling across the prairie, and some beautiful foreground there in that old ford. And sometimes you find abandoned churches or beautiful old church buildings in Saskatchewan, of course, also with this menacing looking shelf cloud in behind. This alone would be a memorable enough storm chase for many chasers on the Canadian prairies. So, it's not always about the tornadoes. Tornadoes are actually very hard to find for the most part. If you're ever out chasing, actually it's recommended that you chase with professionals. You've got years of forecasting experience. You've got years of kind of recognizing how these storms work, the structure of the storms. You can kind of predict their behavior better so that when you're near them, you're documenting them, you're staying safe, right? But most chasers, they're out there doing it because they love the beauty and the power of nature. And as you can see, these are just fantastic scenes. Not many people will lay their eyes on a scene like this. So that's personally part of the allure for me. I mean, part of my story was when I was a kid, I was absolutely terrified by thunderstorms. I was hiding in the basement, plugging my ears and closing my eyes. I didn't want to hear thunder or see lightning or anything. And then as soon as the storm ended, I would beg my parents to take me to the library so I could get picture books and look at the lightning that I just missed. That's and a lot of people had that similar story growing up that are real weather enthusiasts now, is they grew up being terrified of these things, but then they ended up being very fascinated by the thing that they were afraid of. And then, over time you get over your fear. I admit I'm still a little spooked by close lightning. We were chasing down in Texas a few years ago and driving down the road, and we literally almost got vaporized by this giant rogue bolt that jumped out 12 miles away from the storm. Fireball, literally. It hit the ditch right beside us and exploded grass everywhere, and it was terrifying. It sounded like a nuclear blast. So lightning still spooks me out a little bit when I'm outside in it, and I guess that's okay. You should be scared of lightning. But I do know some people that are not that scared of it. But yeah, so that's a little bit of my story. I hope you enjoyed the journey I took you on across Western Canada. And now I guess do we have time for a few questions there? Yeah, perfect. So hit me with your questions. If you have any, I'm happy to take questions on meteorology or experiences or whatever. And yeah.
Oh, for those of you here in the audience, just raise your hand. And for those of you who are participating on Zoom, just use the Q&A function and type in your question, and I will read it out for Kyle to answer to you. So we'll start off with a question here in the house.
Hi, great. Thanks for that presentation. It's fabulous.
Thanks.
I'm sure everyone else thinks that.
Thank you.
But, a couple of little questions here. First of all, I saw some wind turbines in the background there of that storm in Saskatchewan, I think it was, where the shed was leveled and the kitty came out. And how do wind turbines handle this?
Good question. That was actually the Black Spring Ridge wind farm just east of Carmangay, Alberta. So it's still in southern Alberta there. That tornado actually threaded its way between a couple of the turbine towers, so we didn't actually see what would happen. In other cases, I think it's EF2, EF3 winds can actually cause one to topple over. I'm not exactly sure, but so a wind over 200 kilometers an hour. Thank you. That's much better. Over 200 kilometers an hour or so can cause one of those towers to buckle. But there's different heights of those towers. Some of them are 100 meters tall. Some are 50. So yeah, that's a good question. Probably not very good things happen though when they get a direct hit from a strong tornado.
So my question is, how did you get started? Was it Pine Lake for you, or some other specific experience, or a band of friends eventually becoming professionals?
For storm chasing? Okay, so actually interesting story. So I'm dating myself a little bit, but Pine Lake 2000, I was in 9th grade, and we were actually camping 30 minutes away in a place called Red Lodge Provincial Park near Bowden. And so we saw the parent storm go by. It was really eerie. It looked like an atom bomb cloud. I'll never forget that. It got super quiet, passed on by, and then the tornado occurred. And we got the bad news later in the evening. So, but I mean, I think it probably started earlier than that for me. Back on my birthday, June 27th, 1996, the day that, well, there was a tornado in High River that day. So I'm in the 6th grade, just finished grade 6. And we were, as it turns out, going that night with my friends for my birthday party to go see Twister that just came out in theaters. Like, what are the chances of that, right? So, I mean, okay. So, I mean, I've been interested in storms my whole life, had that experience. As soon as I got my driver's license at age 16, I took my mom's minivan and I was driving after storms. It didn't go well a couple of times. I had to explain to my dad why the side view mirrors were smashed before they took the van on a family vacation once, but big hail in Alberta, right? But yeah, so it's been a lifelong passion for me. But yeah, I mean, I've been chasing storms ever since I got my driver's license, and you know, learning through the School of Hard Knocks, a little bit of damage here and there. But yeah, thanks for asking.
All right, thank you. Let's take one from online. Somebody asked, oh, and just by the way, about your thing about being spooked by lightning, and I too am spooked by being nearly vaporized by lightning as well. So it must be a common fear. We have a question from online. What was your most dangerous storm chasing experience?
Okay, the one that comes to mind is southern Saskatchewan 2016 or 17. We were near, it's somewhere around there, near Estevan, Saskatchewan, this monster supercell thunderstorm just trucking along the US border. And we were thinking, well, there could be a tornado with this storm. We want to have like a closer view, because the highway, if you're familiar with Southeast Saskatchewan, goes through like Oxbow and Carnduff. It's further to the north. We were riding literally like 0 Avenue along the border, and it's this little dirt road, which is not a really good idea. Live and learn. You always want to have escape routes away from the storm, multiple escape routes if you have to bail for some reason. So what ended up happening was I'm following the road atlas, and the road is starting to dwindle, and I'm like we have one road out, which is back, and the storm's moving at about 70 kilometers an hour, and on weather radar it's showing very intense hail core and potentially worse, like maybe maybe a tornado in there. We're not sure, but we're trying to stay ahead of it. And sure enough, there's this massive river and the road is gone. And so now we're like, we got to go back. There's no other, we're going to be sitting ducks if we go this way. At least if we go back, we can try to get out of the way. And so we limped our way back into the storm, and we took we rode off the truck in baseball, larger than baseball hail. I would say that's probably the scariest experience. I actually have one of my chase partners here. His name's Darren. He's sitting in the front row there. We had a pretty scary experience in Texas once too, where we were driving down one road and we're like, oh, look at us. We're geniuses. Cause it's like, in Texas, it's mainly a grid across the state. The storm motion was going like kind of on a 45-degree angle, right? So we found one road that was going on a 45-degree angle. We're like, look, we're going to just stick with this storm. It's going to be perfect. But another storm kind of came up behind and caught us from behind and started rotating really hard overhead. And we felt like we had no way out again. So you do have to play careful around these storms. The main thing, you live and learn, you get smarter over the years. But yeah, I mean, weather is weather, and you can't always predict things. Sometimes it's a highly evolving situation. And so the closer you are, the more your head has to be on a swivel.
Perfect. We'll take one from the crowd, and then we'll come back to Zoom, and we'll go backwards and forwards.
My question has to do with hail and the cloud seeding they do with silver iodide. Like, how effective is it? Like, does it take just, as opposed to smaller, really big ones, and then just make a whole bunch of smaller ones?
That's a good question, and I can't officially answer that question. I wish I could. That there is a debate in the community. Does it work? Just anecdotally, as a storm chaser, it does. And again, this is anecdotally. This is not based on any sort of scientific fact. Just being a storm spotter in the field, with weaker storms, we've seen when they are really hammering the storm cloud with the silver iodide, we've seen it weaken. It seems to weaken for a little while. Bigger storms, tornadic thunderstorms, it doesn't seem to make much of a difference. They're just huge storms. Some say that, you know, it might be adding what's called cloud condensation nuclei into the storm, which makes more competition for these hailstones to form. So you get, the theory is that you get more smaller hail rather than a few large damaging hailstones. But I mean, you can't win with hail, right? If it's wind-driven marbles, it's going to destroy your crop more than golf balls will. And it can clog drains and cause flooding. Whereas, you know, if you have if you have a fewer but larger, you're going to write off every vehicle and siding and windows and roofs everywhere. So yeah, you can't win with hail. So that's a good question. There's ongoing research into how effective it is.
Great, thank you. We'll take another one from Zoom. And for those of you on Zoom, you can just use the Q&A function and I will read your question out loud. So somebody on Zoom says, they guess you're likely to experience a lot of dangerous moments, but what are the reasons that you enjoy your job? Because it seems that you love it very much.
Yeah, I mean, it's, as you could see with everything in that slideshow, it's just very, the beauty and the power of nature is just something fantastic to behold. And like I say, for myself, there was that element of, you know, I was afraid of storms when I was a kid. And so it was always just on like sort of a very visceral level, very exciting, very interesting to me. And of course, as someone with a, you know, a science background, I really am interested in trying to understand these storms better. The more we understand, the better we can predict them, the better we can prepare folks for them. So yeah, it's a combination of wanting to contribute and learn about the science, but also it's just, to be straight honest, it's just amazing to witness that in real time. There's a question down here I saw, yeah.
You know, how nature makes an earthquake?
Oh man, geez, do we have any seismologists in here? Yeah, so let's see. I'm a weather guy, but I can try my best here. So for earthquakes, if you picture the earth being like an eggshell, and it's a cracked eggshell. So there's a bunch of cracks in the earth's crust. And these basically are kind of floating, these little shell chunks are floating around on the surface of the earth on top of the kind of molten center of the earth. So the middle part of the earth is liquid, and then the crust is kind of floating around on the outside, really slowly drifting around. So, you know, the earth is really old, but, you know, over time, over several, you know, hundreds of years, sometimes you see one of these what we call faults, they kind of slip along each other, and then you can get an earthquake. And that's how your earthquake happens, is when these, what we call tectonic plates, but just basically these chunks of the earth's crust slide past each other or slip underneath each other. That's how you get an earthquake. If there's any seismologists in here, I apologize if that wasn't really accurate, but that's how I would understand it. How is that, Darren? Darren's from the West Coast. Good. Okay, thanks. Good question.
Awesome. Let's go to one more online. Do you have any special training for storm chasing?
Well, for me, it was trial by fire. But for many folks, there's lots of good options for getting into it safely, mainly through chase tours with reputable organizations, such as in Canada, we only have one through the University of Manitoba. There's also, you know, in the States, there's lots of university programs. There's also tour groups you can go on. So certainly something worth looking into if you're really, you know, wanting to get into it. And the reason for that is because it's just better to have, you know, the expertise in terms of forecasting. You're going to have better luck finding the storms, but you're also going to have more safety around them because, you know, you'll know where not to drive for the most part. So yeah, I would just say that's how I would answer that.
Awesome. Another one from the crowd.
Have you ever seen the damage of an EF5?
I have not. That is a good question. They are very rare. In fact, when was the last? We've had one F5, and this is the Fujita enhanced Fujita scale. In Canada, it used to be the F scale, the Fujita scale. Since 2013 in Canada, it's the enhanced Fujita scale. There's always more development and research being done into like improving the scale. But basically, those are winds in excess of 310 kilometers an hour, and the damage that can do, just absolutely catastrophic damage. So you saw the last kind of sequence of photos there of EF4 wind damage. So it's even worse than that for EF5. So a well-built home, say suburban South Calgary, if it got impacted by an EF4 tornado, it would probably be maybe 1 or 2 walls left standing, like incredible damage. But if it was an EF5, a well-built home, it would be completely slabbed, like gone. So yeah, just incredible damage. We've had one F5 tornado in Canadian history. It was in Ely, Manitoba on June 22nd, 2007, just west of Winnipeg. They certainly can happen. Thankfully, they are very, very rare.
Great. We've got a few more questions here online. Somebody asks, what is a shelf cloud and how do they form?
Oh, I like that. Okay. So here's, the lights are on, that's okay. But you guys remember seeing that big shelf there? Like, and actually, if you look here, if you can see it, there's these multi-layered kind of structures in this striated looking shelf cloud. So a shelf basically forms when the outflow of a thunderstorm, so like the cold, rainy hail breath of the storm comes out from outside the thunderstorm. It's like a wedge that's traveling along, and it actually forces air upwards along the, it's like we call it a gust front. It's the edge of the cold air, the rain cooled air from the storm as it progresses and advances outwards. It literally acts like kind of like a shovel going along and forces the air upwards. And that's how you end up getting these fantastic laminar, we call them laminar structures when they're smooth like this. Turbulent is that crunchy looking, and then laminar, of course, is these nice smooth structures. So basically it's like, it's the rain cooled air progressing out of a thunderstorm and kind of like forcing the air up as it goes. And you get these beautiful shelf cloud structures along the edge. And shelf clouds look very menacing, but they're often, you know, they can be the sign that the storm is weakening, because the storm as it exhales more cold, rain cooled air, it can actually undercut the source of fuel that it's getting through updrafts, through its inflow. And so a shelf cloud can actually be a sign of a dying thunderstorm, but they're very fantastic and beautiful and terrifying to look at all at the same time.
Great. Any questions here in the crowd? We got one at the front over here.
Thank you. Hello, beautiful presentation. Thank you so much.
Thank you.
And now with your experience and chasing all these weather situations, what do you think, or what's your expectation in Calgary for this 2023?
Yeah, this coming year.
Yeah.
That is a good question. I wish I had a really good answer. What's happening? What we will typically look at is analog years. So years that were similar to this in terms of the overall kind of climate picture in the world. And by climate, I'm not talking about long-term climate. I'm talking about shorter-term climate drivers such as El Nino, La Nina. Most folks have heard of that, right? So we've been in a triple dip. That's what the media have been calling it. 3 years in a row, 3 years of La Nina. We are coming out of the La Nina now, and we're expected, according to long-term forecasts, to end up in an El Nino situation again. So that's cold sea surface temperatures, anomalously cold in the eastern tropical Pacific, becoming warmer than normal. And typically that changes, you know, we'll see the cold winters with the La Ninas here, warmer winters with El Nino. But during that transitional period, it can be 6 of this, half dozen of that. Some years, ultimately what will really determine the summer storm season is how much rain we get. If it's a drought, like it's really dry right now out there, if it stays dry through May, June, it'll be disastrous for the agricultural sector, but also severe storms won't have any fuel here in Alberta because like I was talking about those crops, if there's no moisture in the air, you're going to see that drought kind of like drought begets more drought. And that also impact the severe storm season, right? So if we see a very dry spring, we may end up having a very minimal severe storm season, more of like a drought heat wave type situation, kind of like we saw in 2018 and 2021. So right now, just coming out of the La Nina into the El Nino, it could go either way.
Perfect. We got a whole bunch online here, so let's cut through some of these. How do you take care of yourself when storm chasing for many hours, like for food or bathroom breaks, etc.?
Oh man, my wife's here too, as she can attest, I'm horrible at that. Yeah, self-care, the first 3 or 4 years of storm chasing, well, for the Weather Network, yeah, I mean, it's typically go, go, go. Like I was a solo guy a lot of the time. So I'm managing my own cameras, I'm doing my own forecasting, I'm communicating with the team, setting up for live shots. You're just going, and you have deliverables that you have to send in and everything. So you're very busy and you don't have that much time Going to the bathroom, let's not go there. You just try to avoid drinking too much water, I guess, which is not good. But then at the end of the day, you got to drink lots of water, but then that means you can't sleep very well. Yeah, maybe 20 push-ups on the side of the road every now and then. I have a horrible sweet tooth. And so gas station after gas station, it's like, you know what? I'm feeling like I'm going to have another blizzard at the end of today's chase and put on about 20 pounds by the end of the summer. No, it's a very real challenge. Self-care. I've actually really started trying to implement that into my workflow. Basically just force yourself to get up at 7 a.m, go for a run. At least you're going to make sure you do your fitness first thing in the day, and then you'll be set for the rest of the day. And, try to drink more water and eat lots of fiber.
Awesome. Let's go, Robin.
How have you noticed climate change affecting the weather?
Well, yeah, that's always a big question. And I won't get too much into that, but for instance, we see like what we would call like the DNA of climate change in certain events, because climate is you can never attribute climate change specifically to individual weather events. But over time, what you'll see is, like I say, the DNA or the kind of the fingerprints of climate change on those weather events. So one example I will give is that 2021 heat wave in British Columbia. So before 2021, the all-time record high temperature in Canada was 45.0 degrees, set back in the Dust Bowl era in southern Saskatchewan, like 1938 or something like that. Hadn't broken that record for decades. We started approaching it, but then like all of a sudden in 2021, it was like a perfect kind of amalgam of different, drivers that brought this record heat, this heat dome we were talking about, to kind of impact western part of Canada, northwestern parts of the United States, and unprecedented. Like the margin, like when you break a record temperature, it's usually by like 1/10 of a degree. So you would expect, maybe 45.1 in Lytton, 49.6. It's just a massive difference. And we're seeing more of these heat dome type events. With climate change, you would expect a slower jet stream, so more what we call atmospheric blocking, more ridges and troughs getting stuck in certain positions. So you're not necessarily always getting hotter in certain places, but the weather becomes more changeable. Worse droughts, worse floods, more intense heat. So we are seeing some signs of that with certain weather events. So the Lytton BC heat wave in 2021 was an example of that.
Awesome. Let's go back online. It says, my son and I were also chasing the Bergen storm on July 7th, 2022. The tornado made an abrupt right-hand turn and a later funnel made a sudden left turn. What causes these sudden turns?
Good question. So there's various reasons for that. So this storm was basically like when you have a more stationary storm, it just means that the storm relative winds, like the winds that the storm itself are feeling, are different from what we may be feeling on the ground. So the storm it's feeling winds from one direction down low and another direction up high. And in this case, it was actually on a ground relative sense, pretty stationary. And so when you have more stationary severe thunderstorms, tornadoes can take more loopy tracks. And they'll be kind of like he said, the tornado was on the ground for like 30 minutes and it only traveled like 2 or 3 kilometers, and it had a loop in the path, and it turned a hard right at the end, which was unusual. We would typically expect at the end of a tornado's life cycle, as it occludes, that it would actually turn off to the left of the storm motion. So I'm not sure exactly why it turned right, but like he mentioned, there was another cycle, and then another tornado almost formed. A nice funnel cloud came down, and it behaved more in a kind of typical fashion. So the storm had started moving further to the east, and it did hook off to the left, as we would expect with that storm kind of occluding. So if he's a storm chaser, I hope he understood what I was just saying there, but yeah.
No, that's great. Oh, up there. Yep.
Yeah, I don't know how to voice this, but being astronomy types and needing a nice clear nights here in Calgary, it just doesn't seem to happen a lot. And I'm sure you're in Calgary. So at night, because you can come, all day can be clear. This happens again and again and again. But the clouds come rolling in from the west right around dusk, right? This happens again and again. I wonder if do you know what I'm talking about?
Yeah, I mean, I've thought a lot about this. Maybe not so much from an astronomy standpoint, but what I've noticed is that, but I do like I do some, well, it's, I guess aurora photography is not astrophotography, space weather, but we've tried for aurora. And I think it's just luck of the draw in some cases. It just depends on the time of the day. The one thing I have noticed that I'm trying to figure out is that often during the day, throughout the day, you get increasing levels of upper level cloud, but then by early in the morning the next day, it kind of dissipates. And I think that's the result of just like through like certain times of the year, you have more convection occurring during the day. So the air is rising as it's hot and sunny during the day, and you're getting more of that water vapor up into the upper levels of the atmosphere. But once the sun kind of settles down and the sun sets at the end of the day, then that convection shuts down and the skies do clear out, but it takes a few hours. So I mean, yeah, if there was any of that cloud matter kind of built up to the west, perhaps that could be the reason why it's kind of drifting east with the prevailing westerlies. But that's the only way. I would say luck of the draw for me. It's Murphy's law. Like, you know, on the night that you are, you know, a huge coronal mass ejection is hit and you're thinking, oh man, we're going to get an epic show tonight. Like, it's always cloudy, right? And then the next time you're expecting a big aurora show, it's perfectly clear, but then nothing happens. So yeah, it's Murphy's law half the time, but
It's true. Every time I buy a new eyepiece for the telescope, it's cloudy for a week. Where do you foresee weather forecasting technology going?
Weather forecasting technology is rapidly improving compared to like 50 years ago, especially. But today, I mean, eventually, like we have, for example, we have Environment and Climate Change Canada, Weather Network. They all employ human forecasters, and human forecasters are critical to the forecast process. But some would argue that's becoming less so because computer model data. So weather models basically in some, how they work is that you've got observation sites across the surface of the earth. And you also have weather balloons that go up and collect upper air data. And then all of these observations, these real-time observations, are fed into supercomputers where the atmospheric motions, physics of motion are basically applied to them, and then they spit out these basically forecasts and weather model data. Models are getting better and better and better, and they're starting to automate certain forecasts. So like spoiler alert, when you open your phone and you look at like Environment Canada's 7-day forecast, the first 2 days are typically been manipulated by a human forecaster, especially if it's a major center, and they'll say, you know, like, we're going to tweak this a little bit because we think that the model is biased in this direction. But the models are getting better and better. Like, we're not able to beat them as much. So yeah, basically, eventually a lot of weather forecasting is going to be automated in the future as we get better and better at it. But there will always be certain parts to the process that'll need the human touch. I mean, weather warnings, communication to the public, high impact weather, that's always going to be an important feature of weather forecasting. So yeah, our models are getting better. Our ability to predict weather is getting better. Yeah.
That's cool. We'll maybe take a couple more questions and then
Sure.
we can close it off. But we've got some, if there's any questions here in the crowd, you know, maybe you can talk to Kyle afterwards. I just want to get through for the people on Zoom right now. What are your favorite or most important items in your storm chasing kit?
Cameras, lots of cameras. Some folks have like 7 cameras rolling. Depends on how much action you want to capture. I would say a good camera out the dash, 4K video quality. My handheld Kestrel, which is a little handheld anemometer that can kind of measure. You saw me holding it on the mountaintop trying to measure the wind speeds. And what else? What's another good? Yeah, I mean, a good map book. You know, that's another thing. A lot of folks navigate via like Google Maps or whatever, and I'm still kind of old school. I like paper maps because phones fail, technology fails sometimes. But map books can too, as you've heard with the Saskatchewan thing where it said there was a road there and there's no road. So yeah, those are my top 3.
Awesome. What was your most anticlimactic storm chasing experience?
Oh man, that's probably 99% of all storm chases. For people, and that's another kind of deterrent for a lot of noobs. They come out and they're like, man, it was like literally 13 hours of doing nothing. Like, yeah, welcome to storm chasing. My chase partner Darren and I, we've driven all the way to Manitoba and we call it blue sky busting. Like we sat under the big banana in Melita, and it was beautiful blue sky. We got a nice suntan. The storms never materialized, and we drove back to Alberta with the tail between the legs. And I mean, a lot of the time you're literally just waiting, driving, waiting some more, and then nothing happens. So anticlimactic events, I've had several. Yeah, it's mainly when no storms materialize.
Great. Somebody asks, can you have Chinooks in warm weather? And
Yeah, a Chinook is basically just anytime you have lee side warming down a mountain range. So yeah, anytime the air is flowing down the slope of the land, and that can happen in the summer too. It's just as anytime the air is flowing from the west, it's warming via compression as it enters into the lower parts of the atmosphere. The air is more dense. It warms up adiabatically is the scientific term. But it's compressional warming, lee side warming. So you can have Chinooks at any time of the year. And actually that time lapse was showed of those Chinook arches, that was actually shot in June. So you really just need a westerly flow that's stable over the mountains, and you can see those Chinook effects.
cool. What's up with the Farmer's Almanac? It seems to get the forecast correct extremely far in advance, more often than TV and radio stations.
Oh man. Yeah, I would say no comment. Some people really swear by the Farmer's Almanac. It's basically like tossing a coin. So 50-50 odds is pretty good, right? That's all I'm going to say about that.
Cool. Let's just kind of, so have you published a book with these beautiful photographs?
I haven't. The only thing I've published is a storm photo calendar in 2020, but in the future, I just might do that. Would any of you guys buy a book with storm photographs in it like this? Hey, that's great. Yeah, maybe someday I will.
Perfect. Do Chinooks happen anywhere else in the world?
Yeah, definitely. They can happen anywhere. Like I say, that there's lee side warming. So what do I mean by lee side warming is a mountain range. If you have a wind hitting one side of the mountains first, that's the windward side. And then the lee side is the other side. So it crosses over the mountains if it crosses over. And you get the lee side wind, and that whenever it's warming down the lee slope, that's basically a Chinook. So I mean, yeah, they happen down the spine of the continent here, North America. They can happen in the coast ranges, actually, which is where the word Chinook originated, was from the coast ranges, the Northwest states. Argentina, and with the Andes, you can have easterly winds in California called Santa Ana winds, which are also warming downslope winds, but they come from the east. So yeah, they can happen. And in Europe, the other really famous one is called the Föhn, which is the southerly wind from the Alps going from Italy into Switzerland and Germany and Austria. So yeah, they do happen in other parts of the world.
Cool. And our last one from Zoom, very important question. What kind of car insurance do you have?
Yeah, good question. Good insurance, full coverage. Anything else in here, or?
Yeah, I think that gentleman there had a question.
Okay, one more.
I'm assuming that sometimes you go places where you're out of cell range, so you're probably using a sat phone. Do you have any other backups for communication should something go wrong? And also, what do you carry in case, say, your vehicle got tipped over?
Oh man, I don't plan on the vehicle tipping over. I have the typical like storm chasing. It's always a good idea to be driving at least all-wheel drive, 4x4 if you're gonna leave the highway. Typical safety kit, your emergency kit inside the vehicle. I do not carry a sat phone because in most cases, most areas that we go, except for some areas along the foothills that don't have cell reception, most areas have good enough reception that, it may be bad data. Like I'm trying to tweet a video of a tornado I just shot and it's taking an hour to upload. And, people are like, was there a tornado with that storm? Like, yeah, like an hour later, it pops up on social media. But I mean, yeah, if you were chasing off the grid, you definitely would want some other form of communication. But it's not like for instance, like backcountry, like if I'm back climbing a mountain in the middle of nowhere in the mountains, I'm carrying a spot device or some other GPS type device that I can be located. But storm chasing, it's rarely ever an issue. Thank you very much for your participation and all your questions.